Hello, my name is Hrishi, and I'm building something called NOVA-CVS, and this is part of a monthly update that I've been planning to give as I progress with this. NOVA-CVS aims to build digital infrastructure for licensing of nuclear power plants. So this whole digital stack covers the neutronics, the plant, the site itself, and also the regulations. So all of this is obviously done in silos, and what we are hoping to do is to build an API and digital tooling to integrate all of this. Now, this is obviously a very ambitious and a long project, so I'm hoping that as I make progress, I share some of this with you. Now, in this video, we're going to cover some of the neutronics part of it, and I use OpenMC extensively. So I'm going to show you how I use OpenMC, and in subsequent videos, we will talk about other interesting projects that I've been involved in as far as the plant and the regulations are concerned. So let's begin. This is a very simple, let's say, a repository from OpenMSR and MSRE. So this is a sample a Jupyter notebook that talks about running a OpenMC simulation. So if you're familiar with OpenMC, it's a neutronics library. It's open source on GitHub. And essentially what you can do is start to run some things on it. What we are seeing here is essentially the elements being declared, nothing so special about it, the materials, and then some plots, and so on. So essentially, this is how the core neutronics is basically simulated. Now, when you run this notebook, you can see something like this. Basically, this is a output of the Jupyter notebook that I had shared earlier. So essentially, when you do this, this is the output from OpenMC. You can see the pressure vessel and the reactor, and then you have the simulations. And of course, you have then the outputs and so on. So you can go over this in the sort of the OpenMSRE sort of a repository here. Now, what NOVA-CVS does is it automates some of this. So basically, if you go back to this, so basically what you have here on the side is the neutronics aspect of OpenMC, the digital twin with flow sheets and plant visualizer, the site, and the regulations. So as I said, we are trying to bridge the stack vertically, and then we're going to focus today on this OpenMC part of it. When I work with OpenMC, as far as NOVA-CVS is concerned, what we try to do is to store the settings and the materials in the database in NOVA-CVS. So for example, here is how I interact with OpenMC and NOVA-CVS. You have a NOVA-CVS client where I have the URL. I have some capabilities and some OpenMC versions, the workspace, and then I have a set of settings. So for example, this is settings low fidelity and high fidelity, and then the materials. Basically what I'm doing is copying the materials and so on from here, and essentially sort of creating a JSON object. And at the end, I'm saying client.validate settings. So basically these settings are then sent to the server to be validated and stored, and then essentially the materials as well. So what's happening is essentially here, if you look at the settings, I have to select my workspace. Let me just do that. And if I go to settings, here I have the two settings, the materials, graphite, iron ore, salt. So they are all sort of linked to here. And then you have the material mixes, tallies, and so on. But let's go to configurations. If you remember, we had stored two settings. One setting with, let's say, 50 batches and 5 inactive batches, and another setting with 50 batches and 15 inactive batches. And of course, the particles are also different. So we are sort of creating two different settings. And these are stored in NOVA-CVS. And obviously, when you do that, you can do interesting things like compare and do diffs of settings and so on. So it gets really interesting. Then I am creating two configurations. So I'm creating two model runs. So a configuration setting with configuration A and configuration B, and these have IDs associated with it. So for example, that's the ID. Now we have the data written on the database. What I'm going to then do is basically run a simulation. So essentially, the way to do that is over here. I'm connecting to my client, the server that is. I have an OpenMC helper. I have a workspace and model configuration IDs. That's from the server. So I can just, you can imagine automating it. At the moment, it's not automated. It's hard-coded, as you can see. I am getting the model configuration for my workspace and ID. I can then do what basically the MSRE experiment was doing. And then at the end, I'm saying OpenMC run, and then upload the state point file, and then create a state point record. So basically, I'm storing the material and the configuration and so on in NOVA-CVS, downloading them, running my simulation. So you can imagine totally automating it. And then I'm sending back the state point files. So let's take a look at how that looks like. So basically here you have the configurations and the settings that we just already discussed. Once the simulation is run, basically you have two state point files, so nothing so surprising. But what's interesting then is I can start to compare between setting A and setting B, right? So basically what's happening is that the state point files are uploaded. And what I can then say is show me the diff between these two Cali1 results. So you can sort of see essentially that there is a difference because the fidelity is different. And so you can easily compare the difference when it runs. Now, what's interesting here is that I am not using sort of manual files to store these settings and materials. I'm using this database. But it gets even more interesting. Essentially, if you look at the MSRE experiment, you can then start to create these kind of charts for flux and fission and so on. And of course, it's on a plant. But in NOVA-CVS, the way we handle it is basically we have the geo boundaries and the sites, so basically the site. And we also have the digital twin of flow sheets and the plant visualizer. So the digital twin part I will talk about in subsequent videos. There's a very interesting project called Process Forge that we're working on, which is open source. But if you look at the plant visualizer, basically what's happening is that it is downloading it has understanding of the geometry, the plant, and also the tally. So if you look up here, for example, this is my model configuration. I say have it with the tally number B, and then have it as flux of fission. So basically what you will see here, once the geometry is loaded, so you can see here it's loaded. That's the geometry that was in the OpenMSRE experiment, and you can here see them loading the flux and the fission tallies. So you can see here, for example, this chart being loaded, which is exactly the same as the MSRE experiment that was sort of run on the Jupyter notebook. So essentially what we are doing is having a way to manage all of this. So what I eventually want to do is to have this fully automated. Now, this is just the beginning. Some of the next steps that I'm working on is obviously the digital twin, which we will talk about, and also ensuring that the way these, let's say, materials and settings and all the tallies are stored is basically a little bit more robust than what it is. I have a very good, let's say, API at the moment to essentially validate and store these on the database. And now the idea is to really make it robust and eventually have a CLI or a Python library to help store OpenMC settings, materials, and the tallies. And then we use sort of the NOVA-CVS server to explore the results. And eventually, as I said, we will go into other levels of the site part of things, the regulation part of things, and of course, the plant as well. So I hope this was a good introduction to what I'm doing. As I said, I plan to make these short videos every month to share the progress. I'm going to send a contact form. So if you want to have an interest in engaging and sort of just providing feedback to some of this, I would be very happy to talk to you. Thank you so much.